You buddy. Let's do some algebra with words. So what's going to happen? We're going to start doing algebra with words. We got to start getting ourselves in a mindset that sine of x is just a variable, or tangent of theta is a variable. And we're going to have to do all that stuff you learned in your algebra classes in the past. But now we're going to do it with frickin' words. And we're going to factor the following. That's going to be the question on all of them. See, I just got stuff. We're going to factor, and we're going to factor. And it's all with frickin' words. All with words. But dude, let's just start on this one. What if you had y squared minus x squared? Would you know what that is? Would you recognize the difference of squares? Would you know that that's y plus x times y minus x? Know your difference of squares. Know your difference of squares. And so you gotta know this. You just get stuck. So you overuse it, and I overuse it. So we'll get solved. We're gonna perform the same thing. We're just saying right here that y is sine of theta and x is cosine of theta. Right? All the same rules. So this is just write sine plus cosine, sine minus cosine. That's what this is equal. Sine plus cosine, sine minus, cosine. Bang. What's up? Nothing there. Difference of squares. Nothing else to do, just ask us to factor it. All right, we'll simplify something can be simplified. There's nothing to be simplified there. That shit's good. All right. Man, if we set that thing equal to 0, we could solve stuff. All right. Let's go to this one, and it's kind of the same game. So let's look at it again. Let me use the same variables. Let's go y to the 4th minus x to the 4th. All right, back from algebra. But this is actually just y squared minus x squared. You believe me on that? 2 times 2 is 4. So what we've done is we've actually created a something minus something all squared. So it's going to work out in this manner. It's going to be the first thingy plus the second thingy times the first thingy minus the second thingy. But the thingy is no longer just a y or an x. It's a y squared plus x squared and y squared minus x squared. And again, we're claiming that y is not cosine. Y is sine of u, and x is cosine of u. Right up here. So we can look at this and be like, okay, we take y to the 4th minus x to the 4th. That's sine to the 4th of u minus cosine to the 4th of u. And that's going to break down to, that's going to be sine squared plus cosine squared. So let's write this in. It's going to be sine squared of u plus cosine squared of u times, so that's this part, times sine squared of u minus cosine squared of u. Cool, well we factored, but we're not done. Dude, we can keep factoring. That's the same problem as what we started off with. Look right back up here. Dude, sine squared of theta minus cosine squared of theta. The only difference is I'm writing u instead of theta. We just solved that problem. And hopefully you're like, dude, do you know what sine squared plus cosine squared of the same angle equals? Hell yeah, it equals 1. That goes away. And now we're just left with the problem we had from up above. It's actually the same answer. How frickin' weird is trig? All these messed up frickin' identities we can do. So this ends up becoming that sine squared of u minus cosine squared of u, and there's that difference of squares. So sine of u plus cosine of u times sine of u minus cosine of u. That same problem from up above. Weird. Sine to the 4th of an angle minus cosine to the 4th of that same angle is the same exact thing as sine squared minus cosine squared of that angle. Wacky stuff. Okay. We're still factoring. Tangent squared minus 2 times tangent minus 3. We want to factor. Again, We're doing algebra with frickin' words. So just kind of jump aside and be like, all right, let's just let y equal tangent of theta. You know what I mean? Let's just let that equal tangent of theta. So we're like, all right, let's go back in and change it. So anywhere you see the word tangent, we're just going to put in y. So we're like y squared minus 2 times y minus 3. Oh, well, we can do this, can't we? Two numbers multiplied together that equal -3, and then when we add them up, you get -2 all day long, yeah? So that's going to be equal to y, and what are those two numbers multiplied together that equal -3 that sum to be -2? That's -3 and +1, right? It's -3 and +1, because -3 times +1 is -3, -3 plus 1 is equal to -2. Well, we didn't start in terms of y's, we started in terms of tangents, so if we just go right back through and we change everywhere we see a y, and we call it tangent of theta, and there we go. Now, you don't have to change them into y's. This is like training wheels. At the beginning, we use a little bit of training wheels. You're like, dude, I'm not used to seeing frickin' algebra with damn words. I'm used to it with x's and y's, and that shit was hard enough. We're adding an extra layer to it. So you might want to lean on what you already kind of know. You should be familiar with the idea of factoring, at least a trinomial. So we'll keep playing with that. And I got one last problem, and yep, gonna ramp it up a bit. Gonna put that leading coefficient on there. I'll show you the weird uncle. I'm pretty sure I've shown it before in the class. Maybe I haven't. It's just a strange way of factoring, but if you know how to factor, there's no reason you have to do it. You can take it or leave it. All right. This looks like a quadratic. You know what I mean? Like something squared minus some number times something plus 6. It kind of looks like that, huh? If you were to change the secant and say, like, let's let secant of theta equal x. You know what I mean? If we were to let that happen just so we could see it. So why don't we factor what's in purple, and then once we get it factored, we'll just take our x and we'll pop in secant instead. Now, I know for many of us, I know for myself, I hated these. Even when I first started teaching, I didn't know how to teach these. I didn't know how to do it because my teacher, Miss Spiliotis, I still remember her name. She dressed like a witch on Halloween, and I wonder if she's still no way in hell, I'm so old, and she was older at the time, but she was very mean. She would yell at me a lot, but her tactic for solving these was figure it out, just guessing check, and that's how I learned, and I didn't know how to teach it until a brave student in class went, stop that, can I teach you a trick? And after vetting it and looking, it was like, oh no shit. Now, y'all probably have the diamond method, right? Do you remember that? The diamond method or something like that? I purposely don't learn the diamond method. So I am not asking you to change the way you factor. I'm just going to show you a way that I've found to work. If you like it, cool. If you don't, leave it. You're not required to know, nor even understand what I'm about to do. So I'm just going to factor the 2x squared minus 7x plus 6. Take this aside. Now, none of this is going to be equal in the meantime. This is not equal in the meantime. It's a trick. Like how the diamond method is a trick. So I look at this and go, you know what sucks about factoring this? Is that frickin' 2. This 2 right here sucks. And I hate that 2. So we're going to take and we're just going to bring it over to the other side. Now, it's not equal, right? We take the 2 off. And we bring it over to the other side. So you get that 2 times 6. We get x squared minus 7x plus 12. Now I ask you, just factor that. So get down to that point and factor that. And you can. What is this? X's and x's. So two numbers multiplied together equal positive 12, but add up to be -7. So both numbers must be negative. Oh yeah, -4 and -3. Cool. Ah, shoot. That can't be the answer, though. You know what I mean? That can't be the answer. That's not possible. Shoot. Oh, it's that freaking 2 from before. It's got to come back into play. So we bring this 2 down to the bottom. And we put it underneath both the numbers and we try and simplify it. Do you know what 4 divided by 2 is? It's 2. Now this one doesn't reduce, and this is going to happen every time. You're going to have one of them at least. Sometimes both of them don't reduce all the way down. You're going to be stuck with this denominator. We just take the denominator and we put it right here. There's no understanding of what I'm doing here. It's just showing you a trick. And now that's factored. This will only work when you can't factor anything out from the numbers at the beginning. If this would have been something like 2x squared minus 8x plus 6, this trick would not work. You'd have to factor out the 2. It's not going to work. But if they are what's called coprime, you can't factor anything out from them, then this is a perfect method. So here we have it, x minus 2 times 2x minus 3. So you need to be able to factor a leading coefficient trinomial. It happens a lot in this class when we do it. So you need to be able to do this either by my method or how your badass teacher in high school or wherever taught you how to factor. Now we're going to replace all our x's with that secant of theta. So we have secant of theta minus 2 times secant of theta minus 3. And that is our solution. So factoring a leading coefficient trinomial and being able to recognize it with a bunch of frickin' words is your new game. You got to be proficient with it. You have some in your homework, and I think you got some that walk you through it. So good luck. I'll be back with adding and subtracting some fractions and just doing a little bit more general work.